Bivalency allows you that quick change in transcription from here to here by having both of them together, right? So bivalence is absolutely crucial for developmental plasticity. Developmental plasticity, maybe it's important for neural plasticity. Go, because that could be useful there, right? We go research on it. Maybe you'll figure out that now we don't know enough. Maybe we need to work on it. Okay, figure this out. Okay, are you guys all sleepy? Are you guys all sleepy? Some of you are. I can see that. Okay, OCT4, SOX2, NANOC together recruit these factors that are listed on this picture. So essentially, the message I want to give you is they recruit a bunch of chromatin modifying and remodeling factors, and that's how they move nucleosomes. They enable gene transcription of specific kind, okay? And specific gene transcription depends on bivalency, because bivalency will allow you to move one thing in one direction or the other, okay? So active transcription, so OSN is OCT4, SOX2, NANOC. They'll recruit mediator cohescence. You've heard of all of these now. You know, the chromatin remodeler, BAF, TIP60 is a histone acetyltransferase, TRXG, I don't know what that is, okay? But anyways, that we got, you have polymerase that will come through and that will allow the pluripotency cell renewal to happen. This happens, this on top one is only there on the pluripotency stem cell genes, because they have to self-maintain that, right? They have to keep maintaining that. So they'll go there. And poising will be on developmental regulators, which are needed later once I decide to differentiate. But for first order of business is for me to maintain myself, right, into pluripotent state. So that's how they remain active of those. And then they use SETDB1 and the rest of it, as you can see again, okay, including polycomb group proteins, H3K27, SETDB1, H3K9 methylation, if you will, and TIP60 acetyltransferases. They work together to keep the poising happen. All right? Simple. Now you guys must be aware of a lot of these. It's not foreign to you, right? The concepts are simple. Okay, good, hopefully. So that happens, and then that's just to show you that they regulate, use specific chromatin modifying or remodeling factors on specific genes that they know what to do at. Okay, in pluripotency genes, they'll need to maintain it. The other ones, they will need to keep the poising, right? And this is just an experimental evidence for some of it. You see, that's ChIP-seq on the top. The transcription factors bind to the same place. You see peak exactly at the same place. So they bind together at the same place. I showed you their enhancers actually have the sites right next to it. Okay, so they work together. Then they recruit the mediator, which mediates the interaction between enhancer and promoter, right? The big protein complex that we've looked at earlier. Mediator mediates the complex, right? You got this? And that's where it's sitting. Cohesin sits there as well, because we need cohesin for making the loop. And loop will help the enhancer and promoter together, right? In 3D chromatin structure we learned about. Transcription apparatus, obviously you're transcribing, so you need RNA pol 2, and you need Tata binding protein is there. And this is his imagination, Rick Yang's imagination of how it looks. Cool? So you become a scientist, you find experimental evidence, and you imagine how it looks. All right? Imagine, always imagine in your head. What does it look like? It will help you think better. Okay? So he says the transcription factors are need to come here. Cohesin puts them together through mediator and other complexes that allows RNA polymerase to go through, and that happens. Okay? You see why I'm teaching you induced pluripotency cell last? Because this brings together all the concepts that you've learned, at least seem to have learned, hope to have learned. Okay, once this is done, what happens is all those developmental regulators we're talking about are actually next set of transcription factors. So it's called, what you see on the right side is all the key factors now you need to enable next set of programs that will come, because we are complex human beings, right? 23,000 genes, we are complex, 2,200 transcription factors, right? So we are complex features. So this is how it works, but it all has a logic. The logic is OCT4, SOX2, NANOC will come together. They're pioneer transcription factors. They'll recruit a series of transcription factors, etc. next through modulation in chromatin, etc. And then they'll allow that next set of transcription programs to come, occur, and drive the next thing. So you can see they'll mediate, they'll recruit these chromatin proteins on top. They actually are transcribed by them for them to use, first of all, right? So you need that. Otherwise, there is no use of that, no? So they need pluripotency-specific transcription factors first. They'll transcribe them, use them, and in the bottom, they'll change different things, different transcription factor or epigenetic programs that will be required for ectoderm, mesoderm, endoderm, protoectoderm. These are lineages that we are born with, right? That's how you start your journey in this world, from a zygote to these, to next, to become humans, right? So cool. So those are poised initially, and these are all transcribed to maintain the program. It's very systematic. Our best engineers, remember? Cool? That's it. That's the end of my presentation. Message from Mr. Yamanaka. Happy? All right. Any doubts, guys? I wanted to introduce the iPS cells to you because that is crucial. Right? That brings together all the concepts. You guys got some of this. Hopefully some of it. You'll remember it. I can see any failure as a chance. Right? Every problem you face has an opportunity. I'm sure you've heard this many times. I think our great previous president also said this all the time. Scientist, Abdul Kalam sir, right? Didn't he say that? I think I've heard it from one of his quotes. I can see any failure in a chance. Always remember that. I want to leave you with that message. That there are lots of problems in life, there are lots of issues, but you always need to see, what can I do? Where is an opportunity? Where is my business opportunity? Where is my science opportunity, right? Where is my opportunity to make the society better? This is all contributions. I hope you guys will make that going forward in future. Okay? Cool, thank you. And I want to say thank you for your feedback. It wasn't none of the feedbacks I got, but whatever. Thank you so much for listening to me for last 6 days. It was a pleasure teaching you guys. It was a pleasure listening from you, hearing from you, and learning from you. Okay? So thank you for everything you've done. And as who I am, I want to keep on repeating the same things that I do for last six days. Remember, these are simple things you need to do. Focus on it, try to do things. You guys told me about all movies that you watched, lessons you've learned. Please remember those. Definitely dream. Dreams are the way to go. If you don't dream, you're not going to get anywhere. That's the first order of business, right? Work towards it. Never give up. You guys all told me about this in movies that you watched, that you've enjoyed, right? Create health, guys, not wealth. Health. Wealth will come. Wealth will follow it. Saraswati is first and Lakshmi will follow, okay? For sure. Think of folks at the bottom of the hierarchy. I want you guys to get that message. Think of everybody who's at the minimal common denominator. I said lowest common denominator earlier. Think about that, those people at the bottom of the hierarchy. If you think of them, you'll do the right thing. It will all come to you, okay? So if you are the director of an institute, think of the peon of the institute, okay? Because if you can solve that person's problem, you can solve everybody's problem up above that. That's how I look at it, okay? Think of the lowest, minimal, bottom of the hierarchy. Then everything will set apart. Your strategy will be correct. Your execution will be, correct, okay? So that's a leadership lesson for you guys. Love everyone equally, right? There are no biases. Yes, you love your parents and you love everything, right? But love everyone equally, irrespective of their locality. What did I say, right? We all scientists come from different parts of the world. Science brings us together. We create things together. So please don't have your bias when you make not what you want to do. Forgive. We forget that we need to forgive. Okay, forgiving is the most important thing. Remember the lesson we had when we were like, okay, the organizers were bad in that game, right? Don't do that ever, right? Think about forgiving and we're all on the same team. Remember, we're all humans. We're all on the same team. Humanity is the way to go, okay? Humanity is the thing. So we are all on the same team. Never think that you are otherwise. Oh, this person does that person does that. That, I know it's very human to do that, but please try to think that we are on the same team and take care of yourself, because if you didn't, you can't make any difference. So first of all, your health, your thinking is the first. You need to be ensuring that you are able to take care of it. This comes from a very simple but maybe stupid experience. I was with my father for 2 weeks, right? I couldn't do anything for him, and I was just there for him to just say, okay, here is the thing. But he was the one who was suffering. Everyone, each one of us has to suffer through our own things. So please do take care of yourself. If you are not in a good health, nobody else can help you. You can have all the loved ones next to you, but you are the ones who also suffer. So your health is your responsibility. So always think of that. Be humble. I think I was talking to this with Dr. Ashish, right? We're talking about you guys are born here near, or many of you are born here and around, and you actually have inherited the humility from the ground up, okay? So this place will give you that humility that you actually need, and that will make you successful. My PhD advisor at the end of my PhD, when I was fairly successful in my PhD, my first postdoc, and he says, Kunal, you'll be successful because you're very humble. You don't think of what you've got, okay? So I keep that with me all the time. You guys have that luxury. Not everybody gets that. A lot of kids are grown in, they think they own the world or whatever. But you guys, go from here. I've seen that this is a trait of, where you're born, right? Asian people are very humble normally. So please remember that. That's a great trait. Keep with you and you'll be successful. And Dharani, I said that again, you're human first. Please, please, please keep that in mind always. You work towards humanity, nothing else. No nationality, no nothing initially. First, you're a human. Everything else comes secondary, okay? And lastly, innovate, guys. Right? Innovation is what you can do. Every single change that has happened in the world is because of innovation. Somebody thought of little bit of innovation, little bit of change, and that's what we are. We are scientists because we can innovate, right? That's the core competency. If you can't do that, then you're not gonna. I like to keep saying the same thing again and again. So apologies for that, but hopefully you got some lessons, some life lessons here that will be helpful to you over time, beyond epigenetics, which, as I said, winter's coming. Okay, great. Thank you. All right. Do. हाँ नहीं आप लोग आइए मैं खेलवा सर बैठिए सर ऊपर बैठिए इसकी जरूरत नहीं है ना Do we need this? Because I forget this every time.
Good evening, everyone. It's a true honor to express our heartfelt gratitude to. Good evening, everyone. It's a heartfelt gratitude to Dr. Kunal Rai. Over the past week, from August 17 to August 23rd, we have had the immense privilege of hosting Dr. Kunal Rai from MD Anderson Cancer Center. His time with us has been nothing short of transformative. Through his epigenomics lectures, Dr. Rai has not only deepened our understanding of epigenetics, but has also ignited a new passion for scientific inquiry within all of us. Beyond the invaluable knowledge he shared from this field, Dr. Rai's time with us has been a masterclass in intellectual and personal growth. He taught us that the most profound lessons often extend far beyond the pages of textbook and mere serendipity. His insights on life, personality, and perseverance have left an indelible mark on our hearts and minds. As his time with us concludes, we want to extend our sincerest thanks. Dr. Rai, your passion for science and your genuine spirit have been an inspiration to all of us. We are profoundly grateful for the knowledge and wisdom you have shared so generously with all of us. Now, on behalf of everyone from the Department of Biotechnology, Guru Ghasidas Vishwavidyalaya, I would like to call Dr. Santosh Kumar to present this small token of our appreciation as a lasting memento of your time with us. Thank you, sir. I would like to request the participants to come here and experiences.
Good afternoon, everyone. This experience has been very thought provoking for me to say the least, because I don't know how much of epigenetics I got, but the most important thing for me was in the past 6 days, I've had 6 ideas that I think hold potential, and I would be probably pitching to it soon, sir. And I have read at least, if not more, 10 papers in the past 6 days. And to give you an idea, I've read like 2 papers in the past 6 months. So this was a huge deal for me, and definitely it sparked a new interest for me, and I would definitely want to pursue it to some extent. And a huge thank you to sir. Thank you, sir, for everything. And that is all from my side.
These 6 days have been the most provoking 6 days of my life. I would really like to thank Dr. Kunal for that. And he has ignited a spark within me that I didn't know was there. And I'm very grateful for this opportunity. I'm thankful to Santosh sir for organizing this. And that's all. Thank you.
Good afternoon, everyone. Before attending this course, I was just knowing about the epigenetics. That epigenetics is a very booming area. But after Dr. Kunal sir's